Hey guys, and welcome to another video. This is a video in my differentiation series. I've got a few up at the moment, so if you're interested, go have a look. Now, this video is about how to find the equation of a tangent to a curve. Now, I want to break this down a little bit because some people might not actually know what a tangent is, which is an absolutely fine thing to understand or to note. So, let's say I've got a curve. This is not the coordinate, by the way. This is not the graph that the question's asking for. I'm just giving you a generic example. So let's say that's my graph. Sorry about my terrible drawing. If this is my graph, a tangent is, if I zoomed in, a tangent touches a graph at only one point. And it's like a straight line that just touches the specific point. Now that's a terrible drawing, by the way. Please note that I could do a better one. But again, I want you to know if there's a curve, there's a point, is literally a line that just passes the line. And it doesn't necessarily go through the curve, by the way. It could go like that, let's say. That's probably actually a more accurate drawing. So just note is at a specific point. If I had that same curve and I put it higher up, the gradient of that point is going to be different to the one here. Okay, so sometimes they would say, okay, if there's a tangent, that tangent or that straight line is just going to touch that point. Okay, but just remember, a tangent is another word for a straight line. It just so happens that that straight line touches a specific point on another graph. Okay, so it's a straight line. Ignore my terrible drawings. I'm so sorry. All right, here we go. Let's go straight into our question now. It says, determine the equation of the tangent. Remember, tangent means straight line. So this is asking for the equation of a line, which is in the format y equals mx plus c, of course. 2, y equals x squared take 4x plus 3. Okay? So, well, I didn't even give you a point, silly goose. Okay, here's our point. Our point is 3, 0. Okay. So what we're going to need to do, so to be able to do this, you have to be given some sort of point, or you'll be given the gradient. So you could have two different versions. You can be told the gradient already, or you'll be just given a point. Okay. So let's first of all find the gradient. Now you're not told the gradient, but if we remember differentiation, if you differentiate, it gives us the gradient function. And if you've got a curve, and you've got a point, and you've got a tangent, that tangent and that point are going to share, because they are touching, they are sharing the same gradient. So what we're going to do is we're going to find the differentiated version. I still don't really know that terminology, by the way. The differentiated answer to x squared take 4x plus 3. And then because we're given an x coordinate, nice and easy, we'll sub that into it and it'll give us a gradient. So let's do that. So dy dx is 2x take 4 because 2 times 1 is 2. The x stays there. Take 1 away from 2 is 1. So there's an imaginary 1 there, but I don't write it in. Take away 4 times 1 is 4. X to the power of 0, because 1 take 1 is 0, but anything to the power of 0 is 1. So you can see that's why I don't write it in there. And the 3, anything if you differentiate a constant goes to 0, so we ignore it. Let's sub x equals 3. That means the gradient, or dy dx, at this point is 2 times 3, take 4. 6 take 4 is 2. So that means because this point has a gradient of 2, our equation will also have a gradient of 2. So y equals 2x plus c. Hey, but what's the y-intercept? Funny you should ask. Let's substitute it into this point, because we want that tangent is going through this point. So it shares that commonality. It's going to go through that coordinate. So I'm going to substitute in the whole coordinate right now. So I'm going to let x equal 3, y equals 0. And I'm going to solve for c. So that's 0 equals 6 plus c If I rearrange, bring that 6 to the other side, make it negative, my gradient is going to be 2 and my y-intercept is negative 6. Therefore, the 3 dots, y equals 2x take 6. Yep, and that's my answer. So just to recap, if you've got an equation of the tangent and you're given a point and you're given a coordinate, the first thing you'll want to do is differentiate. The second thing you'll want to do is substitute in an x coordinate, okay, to find the gradient. The next thing you'll want to do is substitute in a given coordinate to find C, or the y-intercept of the tangent, by the way. And then the last thing is write your final answer. Okay, and your answer will be in terms of y equals mx plus c. All right, there we go. Thanks for watching, and I'll see you next time. Bye.